Hi there, my name is Maurits Hofkamp. I work as a researcher at Leiden Academy on Vitality and Aging. I'd like to invite you to look at healthy aging from a population perspective. The question we will be asking ourselves is, what could a government or other large health institution do to allow the largest portion of the public to age in a healthier way? Earlier on in this course, we saw that Hans and Kwaku aged in very different ways. Hans aged in a way that we are used to seeing in Western societies. Even before his 70th birthday, he has been diagnosed with diseases such as cardiovascular disease, COPD, and diabetes. Kwaku, on the other hand, has remained free of these diseases till an even older age. Now, strictly speaking, you'd be right if you were to regard Hans and Kwaku as just two individuals who happen to come from different parts of the world. However, there's more to it than that. Hans and Kwaku are typical examples of older people from the respective societies of which they are a member. Their friends all age in a similar way. Hans's friends have age-related diseases too, such as cardiovascular disease and diabetes, whereas Kwaku's friends are virtually all healthier and disease-free. So the Ghanaians and the Dutch, in other words, are two populations that differ in the frequency with which age-related disease occurs, or in their average health, if you'd like. In a way, we can say that the Ghanaian population is healthier in old age. Let us look again at this graph that we also saw in an earlier video. Here we see the distribution of BMI in people over 50 in Ghana, represented by the yellow line, and in the United States, represented by the blue line. Remember that BMI is a risk factor for many age-related diseases, such as cardiovascular disease. The higher one's BMI is today, the higher is one's risk of getting cardiovascular disease in the future. We can see from the graph that among the Americans, there are a lot more people who are considered to be overweight with a BMI of 25 or higher than among the Ghanaians. In fact, about 2/3 of the American population is now overweight, while in Ghana there is almost no one with a BMI over 25. The graph also shows that the shape of the BMI distribution is, in essence, the same in both Ghana and the United States. Both have approximately the shape of a bell curve, although the American curve is wider and shifted to the right. This strongly suggests that whatever it is that's causing the differences in occurrence of age-related diseases between these populations, it exerts its effect on all members of the population to some degree. So it's something, some factor, that all members of the population have in common to some degree that explains the differences in health in old age between the Ghanaian population and the Western populations, like the Dutch and the Americans. You remember that this graph also conveyed another message, which is that it is very unlikely that genetic differences explain why the American distribution is shifted to the right. This becomes clear when we look at the BMI distribution in African Americans, represented here by the green line. As mentioned in an earlier lecture, African Americans are to a large degree of West African descent, and therefore, to the extent that there are any genetic differences between the general American population and the Ghanaian population, differences between African Americans and Ghanaians are probably negligible. So genetic differences cannot explain why Ghanaians age more healthily than Americans. If you followed the course up to this point, you know what it is that can explain the observed differences. Right, it's the environment. So what can we learn from this comparison? Going back to the question we asked ourselves at the beginning of this lecture, can this comparison shine a light on what a government should do to allow the entire population to age healthily? The answer is yes. The comparison shows us that governments should adopt a population strategy to prevent age-related diseases, which means they should try to lower the risk of these diseases in all members of the population. Now, the first scientist to fully recognize the potential of this population strategy in the prevention of disease was the epidemiologist Geoffrey Rose. In the late 80s and early 90s, he argued that those interested in prevention should shift their focus from what he called the high-risk strategy to a population strategy. In the high-risk strategy, which is still a prevailing mode of prevention today, those with the highest risk of disease are targeted for prevention or treatment, so that if we're lucky, the disease may be prevented in some of these people. Now, as Rose pointed out, the potential of this strategy is very limited. Only part of all disease cases can be prevented because only part of those who are at risk are targeted for treatment. What's more, for many diseases, the largest portion of disease cases occur in people who have low to intermediate risk. This is because although these people have a lower risk than those in the high-risk group, they are greater in number and therefore still account for the bulk of the cases. The more promising alternative, then, is the population strategy. In this strategy, all members of the population are targeted so that their disease risk may be lowered. This would be the case if, for instance, the entire risk factor distribution would be shifted to lower values, as shown in this graph. Even if the change in risk is small for any individual in the population, such a shift can prevent many disease cases in the population as a whole, a notion that is sometimes referred to as the prevention paradox. Our comparison of risk factors in Ghana and the United States shows that it should be possible to achieve a shift in risk of age-related disease in Western societies, and that the way to do it would be by changing the shared environment for the entire population. True public health employs such a population strategy to benefit not only those in poorest health, but all members of the society.